Let's look at the uniform distribution of a continuous random variable. Suppose the random variable x is a number chosen at random from the intervals 0 to 100. Find the probability that x is less than 40. Notice that x does not need to be an integer, so it doesn't need to be 0, 1, 2, 3, 4. It could be pi, square root 2, 12 sevenths. Could be any of those. Here's one way to think of it. So we're picking a number from 0 to 100. This is an interval of width 100. And we're finding the probability that x is less than 40. Well, if this is done fairly, then the answer is 40, the width of this interval, over 100, the width of this whole interval. X is an example of a continuous random variable which has what we call a uniform distribution. No number is more likely than another. We call it a uniform distribution. Find the PDF of f of x. We know what PDFs look like. Here's a graph of the PDF. Now, some of the PDFs we've seen, like the normal PDF, is more like this. This doesn't. This is a uniform distribution, so every number is just as likely as any other number. So we need to find this height, okay? For uniform distribution, the PDF f of x is a constant. Let's find the height, because that will be the value of the PDF f of x. So in other words, we need to find this height. It's going to be f of something. F of x equals some constant. In order for f of x to be a PDF, the area under the curve must add up to 1. What's the width of the rectangle? It's 100. The area, all this area is 1. So the width times the height is going to be 100 times the height equals 1. So the height is just going to be 1 divided by 100. In other words, f of x equals 100. So I didn't have the little marks on here, but this is basically 1 over 100. And that's the height of the rectangle. And that's going to be our f of x. F of x is just 1 over 100. More generally, suppose x is a continuous random variable with a uniform distribution on the interval from a to b. Find the PDF of f of x. Same story. Here's the graph of the PDF. Goes from a to b. Let's find the height, because that will be the value of the PDF f of x. In order for f of x to be a PDF, the area under the curve must add up to 1. What's the width of the rectangle? It's b minus a. The area is 1. So width times height, that's the formula for the area of a rectangle. Width times height is going to be b times a, that's the width, times the height, and that equals 1. So the height is 1 over b minus a. Just divide both sides by b minus a. So f of x is 1 over b minus a. What's the mean of x? You might be able to guess this. Hey, it's halfway between a and b. I'd say it's about over here. So the mean is mu equals a plus b over 2, the average, the mean of the endpoints. The variance is sigma squared. That's b minus a squared over 12. I'm not going to prove it. Just trust me with that one. Suppose the random variable x is a number chosen at random from the interval from 10 to 70. Find the probability that x is less than 50. Okay, here's our interval from 10 to 70. So it seems reasonable that the probability would be, this entire interval from 10 to 70, that's going to be 70 minus 10, that's the denominator. The numerator is going to be 50 minus 10. Okay, so we're going to get 40 over 60. In other words, the whole interval has width 60, and the interval we're interested in has width 40. So the answer would be 40 over 60, or 2/3, or 0.667. Now let's find the probability that 40 is less than x is less than 60. Well, it seems reasonable that that would be 60 minus 40, the width of this interval, over the width of the entire interval, namely 70 minus 10, or 60. So we get 20 over 60, which is 1/3, which is 0.333. Find the mean of x. We know what that is. The interval goes from 10 to 70, so the mean is just going to be the average of these endpoints. In other words, it's going to be 10 plus 70 over 2, which is 80 over 2, or 40, which is smack dab in the middle here. And find the variance of x. Well, that's just going to be sigma squared equals b minus a squared over 12, 70 minus 10 squared over 12, which is 60 squared over 12. In other words, 3600 over 12, which is 300. Find the standard deviation of x. I didn't give you the formula for this, but maybe you can figure this out. The standard deviation sigma is the square root of the variance, as always. So that's going to be the square root of 300, because we saw a moment ago that the variance is 300. Speaking of uniform distributions, are birthdays uniformly distributed throughout the year? Close, but not quite. The frequency of birthdays from July to October is higher than expected, and the rest of the year it's a little less than expected.